what you're looking at is three independently isolated, not conducting between each other. They're insulated from each other, these three wires. And I'm going to see how far I can get the spark to go. Rod of fray. Yeah, there it went. I didn't quite touch. They're not, I don't think they're quite touching. I'll have to look at the footage, but I don't believe I'll ever get 4 rods to. Rod of fray. Yeah, I'm getting it to go across. You see the gaps there. Not a whole lot, but it will work. And the two on the left, they are not actually touching at the top there, like you see. I guess you get a better view of it than I do from the side here. Anyway, that's pretty wild. Shoot across 4 air gaps, which makes sense. 1/4 inch. Yeah. Okay, here's a snapshot of those 3 rods, of that last spark. If you notice, it just went in one side, crossed the top of the 2 in the middle, and then out the last one back in the electrode. And that's pretty cool. Okay, what you're looking at now is kind of like the previous video, is I've got 4 independently isolated and insulated pieces of wire sticking up between the electrodes of my Lord Kelvins. And I know that, you know, the bigger your Lord Kelvins, the more water you push through, the more powerful your spark, and the farther it'll jump. What I'm trying to work out here is how far will this jump on my setup. And I shall keep trying. And if I just bring this one in a touch, I'll pull it back, let it capacitate, push it in, and a spark. Pull it back, push it in, pull it back, push it in, and you see in the spark. And it's cool. And like I said, it's all proportion. The bigger the thunderstorm, the farther you can make this gap. Okay, this is the snapshot of the 4 rods, and if you notice, it started off on going into just the first 2 wires, and it just energized those 2. And then the next frame, the second frame, it shows the filaments of the next next 2 rods getting enveloped, but it hasn't materialized quite yet into a full spark. And on the 3rd frame, those materialized into a full spark, and the first 2 disappeared. So it's kind of cool how it took its own sweet time to get across there. Very cool. Okay, what you're looking at now is 5 rods in between the electrodes. And I'm going to see if I can get to cross 1, 2, 3, 4, 5, 6 air gaps. Yeah, there she went. That is 6 gaps. And they're all gapped somewhat, as you can see. It's still sparking across. And this may not be impressive to some of you, but for all I've been through on my little Lord Kelvins, this is a snapshot of the 5 rods, or 6 air gaps. And what's cool on this one is it actually skipped the second rod on the right side. It just skipped right over the top. But on a couple of the other snaps, it did actually hit it. But this one, it skipped it. Thought that was cool. Okay, in conclusion, this is going to be shaky because I'm holding it. Positive ions are conduction. It's going from atom to atom, or molecule from molecule. It's passing along through a conductor. A conductor has the electron functions, which if you've checked out my theory, electrons or electron functions are the static charge that hold atoms together, hold molecules together. And they're timed depending on how many protons are in the atom. It's a time sequence of tick, 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 tick going around. Conductors have the right timed electron functions to pass more current or more gravity than they need. They'll pass it to the next guy, to the next guy, to the next guy, to the next guy. And you'll see a positive ion there because you're going to get an extra electron, as it passes it. You're going to say, well, there's an extra one there. Yeah, because it's giving one it don't need to the next guy as it uses what it needs. But when it gets to the air, when there's an air gap between a conductor and another conductor, you'll see a spark. And the spark is because the air in between them can't conduct that. The electron functions, the electron timing, the electrons can't handle it. They can't handle that amount of acceleration. And so they try and disperse it. And as they disperse outward, spherically radial outward, away from where it's conducting from, the reason you get conduction is because as that spreads out, then it catches the next rod and it says, I found some place to go. So then you get positive ions again. And the negative ions are as the air tries to conduct it, it gets swallowed up. It's like we can't move it from atom to atom to atom that quick. It's not working. We cannot move it that quick. But as it swells out to find enough atoms to move it to, it finds another atom, molecules in this next rod, so it conducts again. Then you get positive ions because it's accelerated again. It's not slowing down, going, where am I going to go? Where am I going to go? And it hits that one and goes, I got a place to go. Then when it goes from the same thing from this one, from the second rod, or the first rod to the second rod, it swells out between them, and then it finds, as it swells out far enough, it'll swell out that distance and make that next connection, next positive ion, bunch of negative ones, positive ion, negative ones. It's a chain reaction. And on the lower Kelvins, you can see that tick, 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 and it happens in an instant. The speed of light, people. Gravity is as fast as the speed of light. I wanted to interject here that the only time you see light is because as the conduction happens, and it's swelling out, and it can't find a place for conduction. When it finally does, the gravity around and the acceleration happening, it's just like it's building a force. It's going, I'm coming out, because I'm accelerated, and normal gravity's like, where are you going? Why are you trying to do it? When it finds that conduction, the place to accelerate to, that acceleration has a place to actually go to, which is what we call a ground, and it hurries up and gets there, you get a pow. That's why you get light between all of them. Wanted to throw that in there. That's why you get light. Now, before you get light, it will conduct infrared rays and infrared EM fields through there, but they're so slow that it doesn't make the air pop into light. But once it gets to the point of capacitance where that's not enough, the inductors have capacitated this electrode up to the point, or whichever, but I'm going to go this way, whichever electrode up to the point where it says, we've got to go. It's like when you really have to go to the bathroom. When it goes, it goes. And when it goes, you get light, and it happens at the speed of light, gravity across here right now. Once it gets across, it goes, hits that receiver, goes up the stream, across the top, back down, to make this receiver be right with the remaining conduction of gravity coming down that it says is wrong for how much this one is capacitating it with. That's all it is. And I will show you in my next video how ions actually work. Thanks for watching.